Okay, so in this video, I'm just going to review some factoring techniques. So first of all, what does it mean to factor? What is factoring? Well, in elementary school, you would have factored numbers. So factoring means to break something apart into a multiplication statement. So for example, 36 is the product of 12 times 3. So we call that a factor pair. It's one way to break apart 36 into a multiplication statement. 9 times 4 or 18 times 2, those are different ways to factor a number. So factoring is just breaking something apart into a multiplication statement or multiplication question. Same thing on the right, you might have done factor trees maybe in grade 7 or 8. So 36 is 4 times 9. And I can keep factoring. So 4 is the product of 2 times 2. 9 is the product of 3 times 3. And what I'm left with is a prime factorization of 36. So I factored it down to the basics, 2 times 2 times 3 times 3, and I can't break it apart anymore into a multiplication statement. So that's what we're doing too in high school. The only difference is instead of just factoring numbers, we're going to factor polynomial expressions, but the idea is the same. I want to break them apart into a multiplication statement, and I want to make it as simple as possible. So you kind of think about prime factoring as I break apart these polynomial expressions. And again, the goal is to rewrite something that here is a sum, so that's a sum of 2 terms or a sum of 3 terms, and I want to instead write it as a product. So the first technique for factoring I'll go over quickly is common factoring. That's where I find the greatest common factor of all the terms. What can I divide all the terms by? Well, 6x plus 30, I can divide them both by 6. And then in the brackets, I'm going to divide both of these terms by 6. So 6x divided by 6 is x. Positive 30 divided by 6 is positive 5. So I've broken this apart into a multiplication. This is 6 multiplied by x plus 5. And whenever we factor, we can always check our answers by distributing or going backwards to get rid of the brackets and end up where I started. And I'm going to do the same thing here. I'm going to look at what they share. In math, the convention is if the polynomial starts with a negative term, I'm going to take out a negative common factor. So 15, 20, and 5, we can say share a negative 5. And all three of these terms also share an x. So my common factor is negative 5x. Then again, I'm just going to divide to see what I write in the bracket. So negative 15x cubed divided by negative 5. Well, negative divided by negative is positive, so I get 3. X cubed divided by x, I have 2 x's left over, so I have x squared. Same thing, positive 20 divided by negative 5 is negative 4. X squared divided by x, well, I'm just left with 1x. 5x divided by negative 5x, well, positive divided by negative is negative. And then anything divided by itself is just 1. So again, I've taken out a common factor. What do they all share? And I've put that out front. And then I'm going to have the same number of terms in my bracket. And again, if I wanted to, I could check my answer by distributing whatever is in front just to make sure I end up back where I started. So that's the first kind of factoring technique that you would have learned in grade 10. We're always going to look for that common factor first. No matter what other method we do, we always want to see at the start of the question is, do they share something, and can we bring that out front to make the problem simpler? The next method we're going to go over is called a simple trinomial. Tri means 3, so I've got 3 terms here. Simple trinomials are in the form ax squared plus bx plus c. That's kind of the standard form of a quadratic relation. And what's important, what makes it simple, is that the a value is 1. So I don't see anything in front of the x squared. It's a coefficient of 1. So just as a review, to factor these, I'm looking for 2 numbers that multiply to my c value and add to my b value. So in this question, I'm looking for 2 numbers that multiply to 21 and add to 10. And once I can find those numbers, in this case 3 times 7 is 21, 3 plus 7 is 10, I can just stick those in my 2 brackets. So I'm going to start with x and x whenever I'm doing a simple trinomial, and I'm just going to put in my 2 numbers, positive 3 and positive 7, and then I'm done. I've fully factored this simple trinomial. And again, if you want to check, you can do FOIL, you can expand. X times x is x squared. X times 7 is 7x. 3 times x is 3x. That makes 10x. And then 3 times 7 is 21. So we can always go backwards to check. So if you ever want to check your answer, you could FOIL. I think I'm drawing those arrows right. And you can kind of get back to where you started. So in the simple trinomial, we're thinking of 2 numbers that multiply to c and add to b. And then sticking those numbers in the brackets. So here's another simple trinomial down here. It's simple because there is just a 1 in front of the x squared. And so immediately I know that my 2 brackets are going to both start with just a single x because those will multiply to make the x squared. If you're working with negatives or bigger numbers, it can sometimes be a little more daunting. I want to think of two numbers that multiply to negative 60 and add to negative 17. What I recommend is just writing out all the factor pairs that multiply to 60. So the quicker you can generate these factor pairs, the less stressful the process becomes. So there's all the pairs that multiplies to 60. If I want them to multiply to a negative, they're going to have to be different signs. Positive times negative makes a negative. And if I want them to add to a negative, the bigger number is going to be negative. So you can play around with your negatives until you get your two numbers. 3 times negative 20 is negative 60. 3 plus negative 20 is negative 17. So I can put positive 3 and negative 20 again. Simple trinomials are one step. It might just take a little work in the margin to generate the factor pair that works. So I would approach this systematically, kind of write down every factor pair that multiplies to your C value, and then play with the negatives until you're happy with the result. After simple trinomials, you can probably guess what's coming next. So the next thing that we're going to look into is complex trinomials. We still have ax squared plus bx plus c. The only difference here is that my a value is not 1. In this case, it's 15. And so what I'm looking for now is two numbers that multiply to a times c, and they're still going to add to b. So instead of just multiplying to 2, they're going to multiply to 2 times 15. So I'm looking for two numbers that multiply to 30 and add to negative 13. And again, I could write out those pairs. What numbers multiply to 30? I think I've just got those four pairs there. If they multiply to a positive, they're both going to be the same sign, and they add to a negative, so they're both going to be negative. So I have negative 3 and negative 10. I can't just stick those right in the bracket, so I'm going to show a few methods to solve this. One method that you might have learned in grade 10 is called decomposition and grouping. So I'm going to put in my two values, negative 10x and negative 3x. The order doesn't matter as long as it's these two kind of magic numbers. And then I finish with a plus 2. So I'm decomposing or splitting apart the middle term. Now the second part of this is called grouping. I'm going to look at what these share. What's the common factor of the first two? Well, they both share a 5x. I'm going to take that out front. I'm going to divide each of these by 5x. So I'm left with 3x, and then negative 10x divided by positive 5x is just negative 2. What do negative 3x and 2 share? They don't really share anything, but everything shares a common factor of a 1. Because this starts as a negative, I'm going to take out a negative 1 as my common factor. So I'm dividing both of these terms by negative 1. So I'm going to be left with, again, 3x minus 2. So if we do this correctly, if we pick the right numbers, we decompose and group correctly, I'm always going to get the same thing in both brackets. And I'm going to take that shared binomial out front as a common factor. So both of these halves of this expression share 3x minus 2, so I can bring it out front. And then I just put the leftovers, 5x minus 1, into my second bracket, and I've fully factored this complex trinomial. So it is a little bit of a longer process. Those two magic numbers don't necessarily show up anywhere in your solution, and you can again check your answer by doing FOIL. You'll always get back to where you started. I'm going to do that exact same question again and just show you a different method. So some teachers call this the Australian method. I'm also going to show you a third method in class called the box method. It starts the same way. I want to find two numbers that multiply to a times c, and then add to b. So they're still multiplying to 30 and adding to negative 13. And in this case, we already figured that out, that it's negative 10 and negative 3. So in the Australian method, I'm going to start by just putting 15x in each brackets. Now, I can't really do that. That's not really correct because 15x times 15x would be 225x squared. It's way too big. So I'm also going to divide by 15. I'll show you what I mean by that in a second. And then I'm just going to put in my two magic numbers in the bracket. So I've got my minus 10 and my minus 3. And now all I'm going to do is reduce each of these binomials as much as I can. So that's another way of saying I'm dividing them by 15. I'm going to divide this first bracket by 5, and I'm left with 3x minus 2. And the second bracket shares a common factor of 3. I'm going to divide both those brackets by 3, and I'm left with 5x minus 1. So we actually get the same solution. This is called the Australian method because I'm putting the a value down under, which is a nickname for Australia. And then I'm just reducing each bracket. Be really careful if you're using this Australian method. It only works I've already taken out any greatest common factor that my trinomial shares before I get started with that method. So 2 ways to do complex trinomials. You're welcome to do whatever you're more comfortable with, whatever you feel is easier. The last kind of factoring method I'm going to talk about in this video is what we call a difference of squares. So in math, difference means subtraction. If you want to find the difference between two people's ages, for example, you would subtract them. So difference means minus. Square means a perfect square, something that I can take a square root of with no decimal. So for example, 9 is a perfect square because the square root of 9 is 3. There's a nice pattern for difference of squares. X squared is a perfect square. 25 is a perfect square. So the square root of x squared is x. The square root of 25 is 5. And I'm going to repeat that in the second bracket. One's going to be minus and one's going to be plus, and I'm already done. So if I have two perfect squares separated by a minus sign, I can just put their square roots in each bracket and have alternating signs. If you try to FOIL, you'll end up back where you started. If you notice, this minus 5x is going to cancel out with the plus 5x. That's why the difference of squares is lacking that middle b term, because they're adding to 0. They can't get too much more complicated. This is about as hard as it can get in the second example here. Again, you have to notice the perfect square. The square root of 9 is 3. The square root of a squared is a. The square root of 121 is 11. The square root of b squared is b. So always going to have your eyes peeled to look for perfect squares. I'm going to have the same thing in both brackets. One's going to be a minus, one's going to be a plus. And I'm done. Just a couple things to be careful about. This one looks pretty easy. They're both perfect squares. However, we've got a positive sign. So that's actually impossible to factor. Nothing multiplies to 16 and adds to 0. So this only works if we have a difference of squares. So we need to see that minus sign in between two perfect squares. This one also looks tempting to do, but this one's also impossible. So 10 is not a perfect square. You can try it in your calculator. The square root of 10 is 3.16, kind of goes on forever. So most integers don't have whole number square roots. So be really careful. You can only do this when I have two perfect squares separated by a negative sign, but it's something to look out for whenever you see a binomial, something with two terms. So they're kind of our main factoring techniques. We went through 4 of them in this video: common factoring, simple trinomial, complex trinomial, and difference of squares. Sometimes we have to combine them and do 2 in 1 question. So the very last 2 examples I'll do on this video are what's called fully factoring. Fully factoring means I'm going to look for a common factor first and then see what I can do. If I see something like this, I don't want to jump to doing a complex trinomial right away. Instead, what I want to see is, what do these 3 terms share? They all share a 4, so I'm going to bring that 4 out front, and I'll put my quotient after I divide in the bracket. So I have x squared minus 7x minus 8. And oh, look, now I've got a simple trinomial, which is much easier and quicker. I just have an x to lead off each bracket. What are 2 numbers that multiply to negative 8 and add to negative 7? Well, I think that's going to be negative 8 and positive 1. Right? Those multiply to a negative and also add to a negative. So I'm going to put those in my brackets, and the order doesn't matter. So that's fully factored. So I'm always going to look to take out that greatest common factor first, and then use one of my other factoring techniques. Same thing here. This doesn't look like a difference of squares. Right? 5 not a perfect square. I've got a plus sign. It doesn't look very conducive to factoring. But if you notice that you have a common factor, it starts with a negative. So I'm definitely going to take out a negative. These both share a 5, and they both share an x. And when I do that, when I divide both of these terms by negative 5x, I'm left with x squared minus 4. Now I do have a difference of squares. These are perfect squares separated by a minus sign, so I can keep going. I leave my common factor out front, and I've got x minus 2, x plus 2. So at the end there, I'm just putting things together. We always want to look for that greatest common factor first, and then we want to start thinking about, well, is it going to be a difference of squares, a simple or a complex trinomial? So that's like a very, hopefully, quick video that recaps what we would have spent weeks or months on in your grade 10 math class. But these are skills that we're going to use almost every day moving forward in your math journey. Okay, thanks for watching, and let me know if you have any questions.